Okay, in this lecture, this is just short lecture which is not part of this course, but definitely we will be studying different fuzzy multi-criteria decision making tools. So you need to understand a little bit about fuzzy set. So most of you people know the basic concept of set. What is a set? What is a universe set? What is a subset? What is a common set? Null set, etc., etc. So in this short video, I'm just going to a little bit explain fuzzy set theory. So fuzzy set theory, the word fuzzy basically came from continental Germanic, which translate to uncertainty, vagueness, or blurriness. So what is uncertainty? When we have no option, when we have no we not know what will be the possible outcome. For example, if you throw a coin, you know the possible outcome. It will be a head or it will be a tail. If you throw a die, you know the possible outcome. So in a situation when you not know that what will be the exact or mean what are the possible outcomes, so in that case we will be using fuzzy set theory, the application of fuzzy set theory. But going to that application, first you need to understand that how you will design a fuzzy set. What is a fuzzy set? What is membership function? Okay, so fuzzy set theory work in fuzzy logic. So maybe you already studied some logic gates in computer science or in some other disciplines. You already know about binary set. Binary set means that you have only two options, two outcomes, yes or no, 0 or 1, true or false, alive or dead, good or bad. But what will be the situation if your boundary is further extended? The choices will be between 0 and 1. Let's suppose this is a binary set, 0 or 1. What will be the scenario if the values lies between? So fuzzy logic expand the decision making set by working between the classic set of decision making, that is 0, 1, true or false, good or bad, yes or no, etc. So first time this approach was introduced by Lutfi-Zadeh in 1965. And he was the first man who first time introduced this fuzzy set, which is an extension of simple set theory. And he derived this to deal with vagueness. Vagueness means where there is some uncertain situation, where the situation is not clear, where there is some blurry things exist. So he used to deal with vagueness and subjective thinking in conventional computer logic, also called binary logic. So at that time he faced some problem which he not solved with binary logic. So at that time he started thinking to develop some extensio tool. So at that time he developed this. Fuzzy logic is used by, so now in these days, as you people know about artificial intelligence, machine learning, so the computer scientists, those who working in computer industry, those who are expert in artificial intelligence, so they also using the fuzzy logic to think like human brain and take decision in uncertain real environment that does not work on binary logic. So the artificial intelligence, for this purpose, it is very powerful that it's behaving, it's think like human brain, which before binary logic was not so strong to design a robot, to design a technology, which also not 100%, but at least 99% think like human brain. In other words, the variable does not have a clear boundary. So in the binary logic, the things are very simple. That means yes or no, 0 or 1. He is a good man, yes or no. But what will be the definition if we further extend this? So in this slide, I'm just going to further explain the concept of fuzzy set theory. So you can see that words like young, tall, good, or high are fuzzy. Why they are fuzzy? Because if you ask someone that what will be the definition of a young, or which mean height will be considered as a tall, and what is the definition of a good or high? So all these terms are a little bit fuzzy as they are continuous value without a binary answer. Young means someone will say that the person whose age is 20 will be young, the person whose age is between 30 and 20 will be young, or the person whose age is 30. So now this is not a binary logic. Binary logic will not be able to solve this problem. So the concept young has no clean boundary, because the concept young has no clean boundary. Similarly, the age, similarly the height, similarly the good. Okay, so because these all terms have no clean boundary, So basically, if you understand the fuzzy logic, so fuzzy logic can solve this problem. Fuzzy logic has many practical applications, and therefore we will be using fuzzy logic and different such like phenomenon in different such like scenario where there is no clean boundary, where there is we wouldn't be able to use the binary logic concept. We have different membership function. So fuzzy set theory uses fuzzy logic and create a new set of work between the binary set. So let's suppose in the above example, the age 20 will be young. So it starts from 20, let's suppose 25, 30. So now this is not a binary. So similarly, you can see that we will further the traditional binary logic, we will further extend this and we will convert that into the fuzzy set. So this is now a fuzzy set. All these values are lying between 0 and 1. So once again, if you ask from someone that do you have a phone, so he will answer you yes or no. So once again, this is just a binary approach, or this is called crisp set. What will be the fuzzy set? For example, if you ask someone that how honest is Ali or how honest or active is Ali, so one say extremely lazy, very lazy, moderately active, very active, extremely active. So now this is the lowest one and this is the highest one, but between lowest and highest there are also some membership function. So now this is not a binary set, this is a fuzzy set. A fuzzy set is a set containing elements that have varying degree of membership in the set. So now in this example we have varying membership function. There are not extremely active and extremely lazy, but there are also some other membership function, and I will discuss what is a membership function. Element in a fuzzy set, because their membership need to be complete, can also be member of other fuzzy set on the same universe. So I will discuss this definition with a very simple example in the coming slide. Element of a fuzzy set are mapped to a universe of membership value using a function theoretic form. So this is called membership function. What a membership function? Basically, this is a curve that defines how each point, this is basically a function which maps each and every point of that set to the universal set. In the input space is mapped to a membership value or degree of membership between 0 and 1. The input space is sometimes referred to as the universe of discourse. So we also call it universal set. And mathematically, we will be write this A is equal to x comma, this is mu ax. So this is basically the element of this set. And this is the membership value. This is the membership value of that set. And x belongs to the universal set, which is x, where ux is called the membership function for the fuzzy set A. X is referred to as the universe of discourse and can be written as a collection of order pair. So basically, a fuzzy set will be in the order pair. There will not be a single entity. It will be in the term of order pair. So you can see this is a membership function and this is in the order pair. So let's suppose while discussing with a simple example that you people understand what is a membership function. Let's suppose we have a set U which is 1, 2, 3, 4, 5, 6. So there are 10 elements in this set. A is a subset of this U set. And the element are 1, 6, 9, 10. So there are 4 elements in this one. How we will construct a fuzzy set from this? So while using the definition of fuzzy set, so A, this head, now as I already mentioned that a fuzzy set will be in the order pairs. So 1, which is the element of this set, and the membership of this is yes mean 1. 1 mean yes, this is an element of this set. 6, yes, this is also an element of this set. 9, which is also an element of this set. 10, which is also an element of this set. So basically, this is the degree of yes. So if in the binary we have yes or no. So if I just write this yes or no. So how we will write this? 1 and 0. So this one, this is basically the degree. This is the degree. And this is called membership value, function value. And this is called the element. So yes, element of this set 10 is belong to this set, and yes, it is an element of this 2. And basically this is the membership function for fuzzy set for this. Okay, this is a simple set. We want to construct a fuzzy set from this. So 2 and the membership function value is 0. 0 means no, this is not an element, this is not belong to this set. Okay, so 2, 0, 3, 0, 4, 0, 5, 0, 7, 0, and 8, 0. If U is a collection of objects denoted generically by X, then a fuzzy set A in U is defined as a set of ordered pair. So basically this is an ordered pair. These are the ordered pair. This is a fuzzy set. A normal set will not be in an ordered pair. So you need to remember a fuzzy set, every element is an ordered pair. So every element of this is a simple set, this is a crisp set, and every element of this, if we construct a fuzzy set, then we will write this in this form. Okay. Further, I will discuss this with a simple another example. For example, U is all students, this is universal set, and G representing good student and S representing bad student. So G, how we will write a fuzzy set, a membership function for this? So G is equal to G comma mu G, where mu, this membership function value, is the degree of goodness, because G is the good students. So how we will write this? Let's suppose A is an element of G and we assigning a membership function value of 0.9. So 0.9 basically basically membership function value, what it do? It measures degree of goodness. So 0.9 is a very high value which is approaching to 1. So all the membership function value are between 0 and 1. But this value representing that A is an element of this set and which representing the membership function value is very high. So that is why mean this is very good student. B is also an element of good student set, but the membership function value is a little bit lower than this one. So this is also a good student, but the membership function, the degree of goodness is 0.7. Similarly, the degree of goodness is 0.1. It's mean it's lowest to 0. C is not very good student. D and the membership function value is 0.03. So it is also better than 0. Similarly, if we construct a fuzzy set for the bad student, so how we will construct this? S is equal to S comma mu S, where mu in this scenario is the bad student, degree of badness. So A, which is also an element of G, A is also an element of S, and because we construct an order pair, as I already mentioned that a fuzzy set every element is an order pair, but we have assigned a very high value which is approaching to 1. The membership function value is 0.9. So 0.9, so that is why the bet A, when in the order pair, this will be 0.1. 0.9 plus 0.1 will be 1. So 1% is, or 10% is A is bad. And here 90% A is good. So mean it's approaching to very good or extremely good. Similarly for B, we have also, this is an element, B is an element of G and B is also an element of S, because both are belongs to the all students, and the membership function value is 0.3, for C 0.9, and for this one is this one. So you need to remember that one element can belongs to one set. So element A and A belongs to both sets, but the order pair will not be same, because A lies in this, the order pair is A 0.9, and the order pair of A in S is 0.1. Similarly for all other, so at this way you will construct a membership function. A membership function is a curve that defines how each point in the input space is mapped to a membership value or degree of membership. So in the previous example, I discussed in great detail degree of goodness and degree of badness between 0 and 1. So the input space is sometimes referred to as a universe of discourse. The only condition a membership function must really satisfy is that it must vary between 0 and 1. So fuzzy set, we will be using triangular fuzzy set, we will be using trapezoidal fuzzy set, we will be using Gaussian fuzzy set, and basically you can also use Likert scale, or just like we use SETI scale from 1 to 9 or from 1 to 10 or from 1 to 100, and sometimes we will also be using the Likert scale, and in that scale we will be transforming qualitative variable or linguistic variable, just like very high, high, moderate, low, very low. So we can also construct a membership function for a fuzzy set. So in this slide you can see the things which I have already discussed. There are different form of membership function. So for triangular, the membership function will be this one. You can see. Okay. For trapezoidal, the membership function will be look this one. For singleton, it will be look like this one. For Gaussian, it will be look like this one. And for piecewise linear, it will be look like this one. So in the multi-criteria decision making, the techniques which I will show you, that how you will use different multi-criteria decision making and how you will utilize the fuzzy state theory in those concepts. So you need to understand. So I mean every triangular membership function, trapezoidal membership function have different membership functions. So a triangular membership function is specified by 3 parameters. A, B, C. Now we splitting the binary logic, for example 0, 1 into 3, A, B, C. A, B, C represent the x coordinate of the 3 vertex. So this is basically that function, membership function, and I already discussed that in great detail. So if x is greater than or less than A, less than or equal to A, it will be 0. If it is lying between A and B, then this will be the value. And if it is lying between B and C, this will be the value. If it is greater than, if it is outside this boundary, it will be considered 0. So this is basically the membership function of triangular. Similarly, for the trapezoidal membership function, this is the trapezoidal membership function. It will be look like this: A, B, C, D. Because trapezoidal, we split that in 4 different dimensions, different parameters. So these are basically 4 parameters. And once again, this is 0, 1. This is that binary logic. But now we splitting this, just like I discussed in the definition of young. 20 age will be considered as a young, 25 will be considered as a young, 30 will be considered as a young, or 35 will be considered as a young. So now this is trapezoidal phenomenon. Similarly, for Gaussian, you can do it like this. So this is just a basic introduction of fuzzy state theory, and now in the coming slides we will discuss some different multi-criteria decision making tools where we will be utilizing this fuzzy set theory. So thank you so much.